Hello, everybody, and welcome to this session called Smarter, Better, Faster, Stronger, New Materials for the Construction Industry. I understand if the concrete industry was a country, it would rank behind China and the United States as the greatest emitter. So solving the construction conundrum is going to be essential if we're going to get to net zero by 2050. So this session, I think, is going to be provide us with a lot of food for thought. And I'd like to thank Dassault Systems for their support in enabling this session. And I'm going to invite Antoine Lafont de Sontenac to join us and say a few words. And I would encourage all of you who are visiting this session from around the world online to pose your questions, and we'll try and get to them. Thank you very much. Antoine.
So hello, everyone. As you said, my name is Antoine Sontenac. I'm working for Dassault Systems. And, well, you must be wondering why us, an engineering software company, is sponsoring a talk around materials and construction decarbonization. Let me give you three reasons. One, we have to decarbonize materials, even in the manufacturing industry. You have heard it many times, materials represent more than 30% of the problem of the greenhouse gases emission. We are committed to help our customers in decarbonizing all their operations, and materials and construction are a must for it. Two, circular economy, as you know, is one of the solutions, and to be used more, repurposed, deconstructed, recycled products and buildings need to be redesigned. We must enable it, and virtual twins can do it. Three, we think disruption will come from the material innovation. Connecting material scientists and engineers could be a way forward to design materials and product jointly to unlock new potential for decarbonization. With Accenture, we estimated that leveraging virtual twin technology could lead to 7.5 gigatons cumulative reduction emissions. And to support these industries, we need to learn how companies design with recycled or biosourced materials and what cement companies need to succeed in their journey. This is why today we are presenting this discussion, and we hope to learn from it and you learn from it.
Right. Thank you. Thanks, everyone, for joining us. My name is Giles Whittell. I'm an editor at Tortoise in my normal life, but I'm delighted to be here with the New York Times. And a lot of very well-informed guests. Those words zip by pretty quickly, but one question that I did cling on to was how will we build our homes? Whatever happens, we're going to go on building homes. And we're going to find out in smarter, better, faster, stronger, how to do so while decarbonizing one of the hardest to decarbonize sectors. I'll do some introductions right at the top because we're lucky to be joined by people from all over the world. Elaine Chow, co-founder of Lingrove, is joining us from Vancouver, British Columbia. Oh, there we are. There she is. Hi, Elaine.
Hi, everyone.
Peter Okwoko from Uganda. Are you actually in Kampala, Peter?
Actually, currently in Costa Rica.
Oh, my
I
goodness.
came for another conference in Costa Rica.
Okay, well, thank you for joining us from there. Maria Mendeluce, I think, is joining us from elsewhere in Glasgow.
Yeah, thank you. Thank you.
I should have said that Peter is co-founder of Takataka Plastics, and Maria is CEO of We Mean Business. And next to me, thank you for coming, Cedric Demuse. Forgive me if I've mispronounced your
That's okay.
surname. Vice President of Group Public Affairs at Holcim. So I think, without further ado, because we've got limited time and we do want to get to some questions, let me go to British Columbia. Elaine, we've spoken a bit before starting this session, but you make a proprietary construction material that is carbon negative. Tell us how it's carbon negative, and, because scale is everything, how you scale it, or how you plan to.
That's a really good question, Giles. And I'll start with a bit of an origin story. Construction here in British Columbia is one of the fastest growing sectors, as is with other parts of the world. And one of these impacts, in addition to climate, is the decimation of our ancient old growth forests. So it gives me a lot of hope that leaders are pledging to protect our old growth forests by 2030. But at the same time, I don't believe we need to wait until 2030 to protect what we cannot afford to lose. And my co-founder, Joe Ludback, started working on our proprietary technology out of the love for these ancient forests. His first success was to replace old growth tonewood for high-end musical instruments with rapidly renewable plant fibers and plant resins. And what you see here is one of the best non-wood instruments on the market. And from that, we've also developed the first version of our product called C.O.O. So C.O.O has been in R&D for close to a decade. We've grown from niche instruments into both decorative surfacing, like what I have here, as well as structural paneling in building and construction products. The reason why we've chosen natural fibers is because they're as strong as performance as aerospace fiberglass. They match the performance of old growth timber, but instead of harvesting in 900 years or even 9 years, our agricultural fibers are harvested in 90 days, sourceable in any part of the world, and sequesters 1.4 tons of carbon per ton of fiber harvested.
Elaine,
so at this kind of scale,
Elaine,
the carbon captured by our product will be the equivalent of 97 million cars off the road. So we're decarbonizing by displacing carbon-intense materials, increasing the use of plant fibers, lightweighting building components, and ultimately avoiding deforestation.
Sorry to interrupt, Elaine. I just wanted to be clear. The fibers that you're using, are they especially good at sequestering carbon, or are they especially good when treated as you do for the material that you make, at fulfilling their materials role, or do they do both?
They do both. So the fibers that we use today are flax fibers. They're low maintenance crop. They're grown all across the world at large quantities. And because we're using these natural fibers in a building and construction product, that means carbon that is sequestered during the growth phase is then locked into 10, 15, 20 years of this building life. So it is both.
Okay, and the second part of the question then, I'm sorry to have interrupted, was how do you plan to scale? How do you build trust in the product and also presumably make it cost competitive with alternatives?
Right. So because these fibers are already grown at such a large scale, we are price competitive. We have been partnering with large partners, such as some of the largest furniture, as well as flooring, ceiling panel manufacturers, to test out, put our materials through standardized tests to prove the functionality of our products. So currently, the path to scale for us, actually, as a market-driven solution, is for consumers to start asking their manufacturers, what are they doing? What are they using in their building products? Where can they put their money? And really start that conversation, start getting material, learn how to read your materials.
Okay, thank you very much. I'm going to scoot on right now, but I think I will try and loop back because I've got a question for everybody at the end. Thanks so much. Peter, again, thanks for joining us. You have a proprietary technology, as I understand it. You operate most of the time in an economy where, is it fair to say, carbon neutrality is, for most of the construction business, a low priority at the moment? I don't know if that's the case, but it's part of my question. Tell us about the material that you make and what the prospects are for really growing to be a significant rather than a fringe player.
Thanks a bunch. Just to re-echo what Elaine said, yeah, construction is a super fast-growing sector in the entire world. And I'll cite an example of my country, Uganda. The construction market alone is at 3 billion USD, and it's estimated to grow at about 10% annually. So with what we bring forth to this sector is a product made from recycled plastics. We are trying to solve two challenges. One, have people get access to construction materials, circular construction materials, but at the same time solve this big problem of plastic waste in Uganda. And in Uganda alone, every day, more than 600 tons of plastic waste is generated. So we saw this as a niche to come out with a solution. One, to solve the plastic waste problem, but also like to come out with some construction products. And we derived a solution to transform these plastic wastes into wall tiles. And the wall tiles are entirely made from PET plastics, that is like the soda bottles and the water bottles. And through that, from every kilogram of a wall tile that we make, from every 1 kilogram of plastic waste that we recycle into these products, we are actually offsetting about 2.2 kilograms of CO2 from being emitted to the environment, to the atmosphere. And I mean, just like any other developing country, the practices around plastic waste management is most people just ban them. Like they think, actually they've been groomed to think that banning waste is the solution, is the only way to manage the waste. So like, instead of banning this waste, how about we transform them into a product that everyone can utilize in the construction industry? That's when we came out with this wall tile.
Okay, so there's the technology that you're using, but the circularity of the process, does that depend on partners for whom you've had to offer incentives? How do you, is it easy just to accumulate the plastic that is the raw material? Do you have to, how do you get it? Is there another business that does that for you?
Well, we partner with a lot of companies and individuals. We work closely with the informal sector. We have this number of individuals who move around the cities collecting plastics, and then they bring them to our facility. But we've also devised innovative ways, because I mean, if you tell people that, well, we're going to buy the plastics, that you're not changing a thing, because people will just do it because you'll give them money. So we've devised ways of having the population freely bring the plastics to our facilities. We've set up plastic banks in major public places in our city, where people come and deposit these plastics, and after which we send our team to go and collect the plastics. We've also partnered with another company that does shredding of the plastics. So they collect plastics and shred it, then bring it to our facility for recycling.
By the way, one more question quickly. Is it an important part of your business model that one of your raw materials is it essentially free?
Yeah, it's part of it. But we've forecasted that in the next 1 year, yeah, most likely we'll have to buy most of these materials.
Okay. You'll actually be buying PET?
Yeah, we'll be buying PET, yeah.
Okay. Great, thank you so much. I want to come to Cedric, who's sitting here next to me. Cedric, you will have heard on the way in concrete, which I appreciate is distinct from cement, but if considered as a country, would be a very high emitting country. Another statistic, construction, broadly defined, 38% of global emissions. We hear a lot about the potential for decarbonizing cement. Tell us how it's done and whether it is feasible at scale.
Thanks for the question. I could give you a long, very technical, boring answer, which clearly I'm not.
I wouldn't be bored, but we would run out of time.
Which I'm not going to do. But I'd like to cover two things.
Yeah.
Straight the cement and your question itself, but also something that goes beyond just our boundary in the material itself.
Yeah.
So how do we decarbonize cement? Today's technology can bring us very far. Ranging from alternative material. Peter mentioned the use of waste, non-recyclable waste. That applies to us too. Some of the waste that comes from the steel industry is reused as a raw material in our industry. All of that can be applied to the max where these materials are available. We can defossilize our energy. Some of our plants in Austria, for example, are largely decarbonized. Last year, they ran for 3 months on zero fossil fuel energy. We can do that, and this can be done on a much larger scale. We can apply circular models. In some countries, we have a cement that contains up to 50% recycled materials. So that means you bring a building down, you recover the concrete, you prepare it, and you make new concrete with it. So it's direct circular economy, and that's enabled us to launch on the market a global brand. We call it EcoPack, it's a fancy name, that has a minimum 30 to 70% reduced embodied carbon. So that's today's technology. Right. Now, there is also advanced technologies such as carbon capture and usage and storage. Yeah. These are technologies that need to be brought up to scale, that need to be developed, but it's not just capturing it in our cement factories. It's about once you've captured it, you need to reuse it, reuse right. CO2 as a raw materials for e-fuels or agriculture. There are many different avenues, or you need to transform it into a materials through a process called carbonation, or you store it geologically, and that depends where you are, where is the demand, what is the infrastructure available to do that, and it's a little bit beyond our industry. This is more a societal endeavor, which involves government, which involves regulation. In some countries, you're allowed to put it underground, in other countries, you're not. So it's very variable, it's not a unique solution. And then you've got the digital agenda. So here, it's totally beyond just ourselves, but it's working with architects using computational design, right. Which allows you to build infrastructure that requires at least 50% less material for the same strength, for the same structure. We did a bridge for the Venice Biennale called Striatus, and that's exactly what it is. It's mixing computational design, 3D printing, advanced materials, and that brings you to minus 70% embedded CO2 for instance, that was a bridge, but for that bridge that has the same structural capacity right. than a conventional one. So if I may, that was the first bit. I quickly go to the second element, and I'm asking the question: is it all about decarbonizing cement or any other material? The context in my question: that over the next 30 years, we're going to put 2.5 billion people in cities, and World Bank tells us that 60% of the infrastructure needed to host these people remains to be built. So we are going to build massively over the next 30 years, and the question: how are we going to do that in a decarbonized way? And we will need all of the solution, Helen's solution, Peter's solution, our solution. And hence the agenda, in my perspective, is first and foremost a performance agenda. So what we build, a bridge, a multi-story building, what is the performance of that infrastructure in terms of CO2 over its life cycle? What is a 1.5 degree aligned building? Mm-hmm. And that's what we need, in my view, to define in priority. And then from industry, we will innovate. Peter and Elaine will continue to innovate and provide response to the market, which will vary from market to market depending on what raw materials are available. So I think it's really important to keep in mind the broader perspective of the end product, the bridge, the train station, the infrastructure that we build. What is the performance? What makes it Paris-aligned? And that's where we also need innovation, because it involves standards, regulation, public procurement, so on and so forth.
But is there a decarbonized version of cement itself? Is there such a thing? I mean, you've explained how you can decarbonize it as far as possible by using different energy sources, and I didn't know that you could presumably crush it up and start again as a sort of low-tech form of recycling. But I was under the impression that you can actually go back to the beginning and create a new, much less carbon-intensive building material, call it whatever you like, that fulfills the same purpose. Is that true or not?
There's a variety of solutions. Let's say the conventional concrete today, we have put on the market concrete that have minimum 30% embedded CO2 compared to the classic, all the way to 70%. And we can go to 100% if that is the project's requirement. And this last mile today is offset locally. Right. It's not for us, it's for the client, it's for the project. You have other technologies. We have a partnership with a company called Solidia, which is not a hydraulic product, it's a carbonated product. So concrete solidifies by using CO2, so it absorbs CO2. So it's in effect, it's a CO2 negative product. Right. But that product today can be used for specific application, such as paving. So there's not a magic solution that will solve, or provides a silver bullet, if you want. Right. So we have a myriad innovation, but I think, referring back to the global construction challenge that we're facing, what we need is innovation scale. And we will need all of this innovation, all of them, and bring them to scale as fast as possible.
Okay, thank you very much. Maria, listening from, well, I heard the blue zone, but I'm not sure if you're in the blue zone. Tell us a bit about what your group does, in particular the Mission Possible Partnership, because as I understand it, you're working with business, we mean business, to decarbonize a lot of really tough to abate high carbon sectors, including cement, steel, chemicals, this kind of thing. Let's try and keep the focus on construction. What are the most promising avenues of endeavor that you are involved in or have seen?
Well, thank you. So my organization is working with Rocky Mountains Institute, our ETC, and the World Economic Forum in the Mission Possible Partnership. And our objective is to accelerate the decarbonization of the 7 highest emitting sectors across geographies to build a prosperous economy for all. Within those, we have 3 that are fundamental for the construction sector. It's cement and concrete, it's steel, and it is chemicals. And we start with high ambition companies that want to create the transition plan. So we create a roadmap and a transition plan on how those sectors need to decarbonize. Of course, we need all solutions, as Cedric and Elaine and Peter have highlighted. So we're not picking and choosing, and we need to decarbonize them all. And here, maybe the theory of change is different. Normally, companies will decarbonize themselves, but what we are thinking is that to go faster, we need to pull other sectors. We need to pull the demand. So this means companies that commit to buy zero emissions steel or zero emissions concrete, or to buy the materials that Elaine and Peter are producing. And that demand signal is really important. Then we have the investors that need to decarbonize their portfolios. They're also talking to these companies to tell them, you need to decarbonize faster as well. And then there is regulation. So when we put together the demand, the innovation, the finance, and the regulation, we think we can achieve that roadmap faster, and that roadmap needs to be net zero. So this is what we're trying to do. We're working with leading companies, including Lafarge Holcim and other cement and concrete producers. And here, the thing is not 2050. The thing is, what can we do from now until 2030? Because the urgency, it's huge, right? And as you mentioned before, for the alternative materials that Peter and Elaine are doing, the issue is how do we scale those, right? From being a small projects to actually being accessible to the wider population. And that's what is coming out of Glasgow on the corridor. It's not about the why or the what, it's about the how and how fast.
Maria, the innovate, you said demand, innovation, finance. There was one other pillar, and I failed to write it down. What was it?
Yes, it's regulation and, of course, technology.
Right. And I do want to come back to that, unsexy as it sounds. I want to come back to that before we run out of time. But on the innovation, thinking of the work that Elaine and Peter are doing, do you work with the small startups as well as big institutions? What hope can you offer them? I mean, heaven knows they are managing just fine as they are. But I'm just wondering if your type of initiative might help people in their position.
So Mission Possible Partnership is looking to these high ambition companies, large companies, but we also have a project which is called the SME Climate Hub that is looking at how to help decarbonize SMEs by providing a one-stop shop. But in general, my advice to Elaine and Peter is that most of the emissions from large companies and small companies come from the supply chain. And a lot of them, between 50 and 95%, a lot of them come from these hard-to-abate sectors, which is the materials and transport. So within the materials, I think it is about providing these solutions to companies that need to decarbonize their supply chain emissions. And while this is, we're going to see more and more demand for these solutions. And so the SME Climate Hub would be a fantastic starting point.
Thank you. Elaine and Pete, I just want to come back to you guys both with pretty much the same question, which is, we can salute your innovation, and you've both got, as far as I can tell, proprietary IP that you're bringing to market. What are the sort of barriers to entry that you're finding? First of all, in British Columbia, is the broader industry welcoming, or is it tough?
Thank you for that question. We're actually getting more inbound than we know what to do with. What is between us and scale are more machinery. We have developed our technology on machinery that exists today. And so for us, it's a matter of getting investments, getting the demo plant, getting additional plants. The natural fibers that we use, as I said, are sourceable any part of the world. And therefore, we can set up manufacturing sites close to the build sites, close to these urban centers to reduce emission across the value chain. So for us, it's a matter of, yes, we are seeing the demand signals. We're seeing manufacturers come to us for our solution. And the part that Maria mentioned, the regulation and the investment, is really what kicks us up to the next gear. We're able to produce thousands of square foot today. We look forward to targeting 100 million square foot on an annual basis. And that's really it. We're not talking about rocket science machinery. Let us set up some plants and we'll show you what we can do.
Thank you. Peter, maybe we shouldn't be talking about barriers to entry. Maybe your view is entirely of opportunity, but I suspect that's never the case when you're starting out, is it? Talk us through the obstacles that have to be overcome, including finance, if that's one of them.
I'll start with the very first obstacle as far as our initiative is concerned, and that is regulations and standards. Recycled products are relatively new products in developing countries like Uganda, and our national Bureau of Standards don't have the standards for recycled plastic tiles. So it gives us a lot of time, and like we have to push hard to look for standards elsewhere and present it to such bodies so that we get approval of our products. Then the other challenge is unfair tax treatments by the tax bodies in countries like Uganda. I mean, we are a startup company. We are barely 2 years old, and the way the tax bodies treat social enterprises like Takataka Plastics is the same way they treat entities like Coca-Cola, big companies, the polluters and all that. You're required to go through all those tax. I mean, there is hardly no tax exemption on some of the activities that we execute. But all in all, the reception of the new products is pretty good. People are willing to use these products, and our focus for the next 1 year is to scale up and be in position to recycle up to 9 tons of plastic waste every month into these products, into the wall tiles.
Okay, well, here we are in the essential, if somewhat dry, topic of regulation. And before we come to questions, and please, guys, do raise your hand if I can see them through the lights in a few minutes, but I want to give all 4 of our speakers a chance to identify one particular regulatory change that would help, well, Elaine and Peter scale, and you, Cedric, decarbonize, whether it's in terms of lowering the carbon intensity of existing products or producing new ones. And again, Maria, I am on the hunt for silver bullets, a regulatory silver bullet. But Peter, since we've got the camera on you at the moment, would I be right in saying that favourable tax treatment would be the single most valuable letter you got from the government?
Yeah, you would be right. Then the other one is besides that, it would be nice if the government pushes hard and enforces the extended producer responsibility, like for big companies like Coca-Cola and Pepsi that are like polluting the environment and doing all this stuff. Like, yeah, figure out a way of having them try to play a part in the solution as well.
Thank you. Elaine, what do you need from the regulators?
Right, so, it's a carrot and a stick, right? In order to improve competitiveness of our alternative materials, there has to be a stick on one end that de-incentivizes incumbent materials, as well as incentives for building projects to include more bio-based, more recycled components. I think as we see that shift, as we see more favorable regulatory climate, that will really help drive adaptation of our materials as well.
Okay, thank you. Cedric, what do you need from the regulators?
Among my long shopping list, I would say on top of it, you find carbon pricing.
Right.
Because at the end of the day, it's about building the business case, to build net zero. And that business case comes from the consumer, the homeowner, the infrastructure builder, as well as ourselves, to invest in next generation materials or next generation technologies in our cement plants. And the business case largely remains to be built. And don't misunderstand me. There's no question on the commitment. We've got our SBTI green-lighted 2050 roadmap with intermediate 2030 target. We're fully committed. But you need to bring it from there to the ground. And one element that can really help to build the business case is to have innovation in how we use carbon pricing. Today, where there is carbon pricing scheme is largely driven at players like ourselves, like big manufacturer. If I look at what's happening in Europe, what is the impact of the emissions trading scheme on decisions that are taken much higher in the value chain,
right,
like an architect, for example, or an engineering company? The answer is zero. So
But you're saying it should be big.
So we should innovate in the way we use carbon pricing so that it becomes relevant for the full value chain.
Yeah.
And this is not to pass, I'm not saying this in a way that we have to pass the burden from one to the other. It's not at all about that. It's about making carbon performance a real decision-making element at all stages of construction, from consumption to procurement to execution to throughout the whole life cycle. And if we use carbon pricing that covers that full value chain, so both the supply, both ourselves, and the demand, the consumer, at the end of the day, if you are more cost competitive because you are decarbonated, that's where we need to land.
Right.
Today, the decarbonized products that I mentioned have a green premium. Where we'll have to go at the next step is to make sure that green premium works the other way. The more carbonated we are, the more of a premium you will pay, and the more we will be competitive with decarbonized solutions. And that's, I think, how carbon pricing is a fundamental element for the full value chain to transition.
Okay, Maria, I see you nodding, and I do want to give as much of the remaining time as possible to questions if there are any. But Maria, why are you nodding so furiously at carbon pricing, and how would you do it?
Well, I think it's really obvious. We need to put a price on the externalities now, on carbon and others, plastic waste, etc., so that then we minimize the impact, those impacts. So completely agree with Cedric. Now, in the absence of carbon pricing, or when the carbon pricing cannot give that signal, then we have procurement, green procurement. It's the next one, which is kind of like an incentive. So incentives, green procurement, etc. But the idea is how can we scale the use of those materials? Also, those materials with the scale will reduce their cost and will become even more competitive. But absolutely, carbon pricing needs to be there. And then, as we said before, standards. So some of these products are new, and so they have less concrete or the plastic element, etc. So these products need to be approved. And I have to say that the governments are a little bit slow, and we don't have time to lose. So they need to accelerate. If we really mean transformation, reducing emissions, halving emissions by 2030, they absolutely need to hurry up with the regulation that will help the sectors decarbonize.
Thank you, Maria. Yes, so we'll come to this lady at the front, and then you, sir, and then you, sir.
Hi, my name is Jordan, and I work with the Natural Resources Defense Council, but my background is in construction management. So this question's for Elaine. At the beginning, you said that your path to scale is through consumer demand, which surprised me initially thinking about, the standards in the construction industry today. So I was hoping that when you say consumers, you could explain exactly what parties in the construction industry that you're referring to. And then to Cedric's point about the lack of business case, can you elaborate a little bit more on Lingrove's marketing strategy to procurement specialists, and specifically where in the world you're seeing the biggest demand for your product's growth?
Okay, we'll start with Elaine, and we'll try and keep things reasonably concise so that we can get the other questions in.
Yeah, and thank you for that question. I do want to mention we have an extended Q&A after this for Lingrove folks. So if you're curious and I didn't get to answer your question, visit our site for that meeting link. So part of it is natural fiber composites aren't the way we use it is not very common in construction industry. And so some of that market is coming from interior designers, and some of that is from, as you said, procurement. Really, wow. Right, so when I say market demand, I'm talking about obstacles that we face when we're scaling with larger companies. So typically what we do is we work with larger manufacturers. We're talking about ceiling panels, flooring panels, and we're trying to displace some of the more carbon intense products that they use today. And so when we're in that process, it is multi-stakeholder. We go from the chief technology officer all the way down to the operator who is managing the presses, fabricating these products. And during that chain, we often get pushback because it is a new material, because it does take some R&D to get products to market-ready state. And I think in that chain, there is opportunity for stakeholders to say, hey, this is something that's worth the time and investment to incorporate into our products. So I'm sorry if that was a little confusing, but I think part of the demand is not just the end consumer, but to answer this question more fully, it is the whole manufacturing industry to see and to be willing to accept the changes that we're introducing.
So you're answering a question that you're offering an answer to a question a lot of people are asking. How do we? Let's move on to the question that was asked of you, and not least, where in the world is demand growing fastest?
Well, look, the obvious answer is that you have more pull in countries where you have a more elaborated regulatory framework, where you have carbon pricing, and that's where you will see a more dynamic market demand. But we don't stop there. You can do it everywhere. We've released these products on 25 markets so far. And look, the first large-scale 3D printing project, which has schools that are in use today, that we did was in Malawi earlier this year. So, you know, I think you need both rely on the market pull, but you can also do market push, and in the end build the demand where you are.
Okay. But Malawi is not, just to be clear, Malawi is not where demand is growing fastest for you. It's where you did the 3D project.
Yes, but what I'm saying there is that we shouldn't just rely on so-called more mature markets where you have a more elaborated regulatory framework.
Right.
We can do it everywhere, and of course, your market demand is more dynamic in Europe, in
right.
North America, and so on.
Thank you. Do we have a microphone over here? Yes, thanks.
Can you hear me?
Yep.
Yes.
Okay, Bomi Fagbemi from Bioloop Biorefinery in Nigeria. I wanted to ask Elaine and Peter, where do you see your technology in maybe the next 5-10 years? Do you feel like you can impact, housing crisis in developing countries? And also to Cedric, what is subsidiaries like Lafarge? What do they do in developing countries as well? How can you push that forward? How can you, like we said, bigger, faster, stronger? I've seen, collapsing buildings in Lagos, Nigeria. How can we, eliminate that, give people cheaper housing and things like that? And what's the pathway towards that?
Thank you. Let's try and answer this quickly. In 5 or 10 years, Elaine.
So in 5 or 10 years, we see natural fiber composites being made everywhere around the world, including developing countries. One of the reasons why we chose the natural fibers that we did is because they grow all across the world. And so, I can't answer directly to the housing crisis, but I can say the product that we're building will provide jobs, not just here in North America, but across the world.
Thank you. Peter.
Yeah, in 5 or 10 years, our solutions can easily be replicated. So I see our solutions across East Africa, and if all goes well, even to other parts of Africa.
Thank you. Cedric.
It's a difficult question to answer. What I can tell you is that where we see it, we need to develop, and we are developing a closer relationship with all the different parties that form the value chain, with governments, developing local skills. I mentioned the use of large-scale 3D printing in Malawi. That was purely local know-how, local workforce. Of course, you bring the robotic from somewhere else, but it was all put into place there. So we have solutions. We can do affordable housing at scale. It's about sitting at the right table, around the table, with the local authorities, with the different parts of the construction value chain, and having a common vision on how we actually bring this on the ground, because we can do it. So it's a question of really bringing the value chain together, and that applies in developing countries as well as developed countries. I think the recipe is the problems are different to solve. The recipe, if you want, is similar.
I'm sure we could go on a long time about that, not least asking you if happy. But let's get one more question. Thanks.
Hi, thank you for the discussion. Just a quick question really about what's dominated media headlines in the UK in particular, but this is obviously a global issue, and that's relating to industry headwinds, specifically supply chain, raw material, labour shortages. So some of these new technologies, do you think they're going to become more or less viable for the construction sector moving forward if these headwinds are more protracted than expected?
Maria, let's come to you since the others, you've only got about 30 seconds. Supply chains in the UK, is it going to get better or worse for construction?
Well, I think as we're seeing with energy, renewable materials, have are much, that are locally produced have more chances as well, to be a buffer in these times where the supply chains are interrupted. So I do think that there is a portfolio of solutions and some, and we need to manage those so that we can afford some of the changes that are happening and these disruptions in supply chains.
Maria, Elaine, Peter, Cedric, 45 minutes is very short when we're trying to hear from everybody and questions, but thank you all very much for joining us. It just feels great to get voices from all over the world and real innovators at what used to be called the coal face, but we're going to call it the natural fiber face. Thank you very much for joining us, and we'll see you again soon.
Thank you.